Alright, what's up everybody? It's Professor Hustlenomics here. We're gonna do a little telescoping series real quick, you know what I'm saying? So let's get started. Alright, our example is going to be the summation of n equals 1 to infinity of 1 over 2n plus 3 minus 1 over 2n plus 1. So the first thing we're going to do is we are going to find our partial sum, which is s of n. So very simple, very easy. We just plug in 1, which is 1 over 2 times 1 plus 3, 1/5 minus 2 times 1 plus 1 plus when n equals, so this would be when k equals 1, k equals 2. We're going to have 1 over 2 times 2 plus 3, which is 1/7, minus 1 over 2 times 2 plus 1, which is 1/5, plus we have when k equals 3, we have 1 over 2 times 3, 6 plus 3 is 9, 1/9, minus 1 over 2 times 3, 6 plus 1 is 1/7. And so we're going to start working a little bit backwards here. Let's hope I don't lose you. And so real simple, when we have k equals n, we just have the original 1 minus 1 over 2n plus 3, and so when k equals n minus 1, well then we would have 1 over 2n minus 1 plus 1 minus 1 over 2 times n minus 1 plus 3. I'm gonna move this monofocal right here. That's when k equals n minus 1, and so finally we have when k equals n minus 2, we have 1 over 2 times n minus 2 plus 1 minus 1 over 2 times n minus 2 plus 3. And so, well, that's a really ugly 2. And so if we simplify this right here, we will get 1 over 2 times n is 2n minus 4 plus 3. That would be 2n, negative 4 plus 3 is 1. Minus 1 over 2 times n minus 4 plus 1. Negative 4 plus 1 is negative 3, so it would be 2n minus 3 plus 1 over 2 times n minus 2 plus 6, negative 2 plus, my bad, negative 2 plus 3, that would be 1 over 2n. Negative 2 plus 3 would be plus 1 minus 1 over 2n minus 2 plus 1, that would be 2n. Negative 2 plus 1 would be negative 1. And if we continue to simplify, we would just get the same thing here, which is the original series, minus 1 over 2n plus 1, provided that we simplified. So these this list of terms is the same one as this one right here. So if we take a look at what is going to simplify, now when you're doing this, you're normally looking for a pattern, and so the pattern here will be the first fraction. It cancels out with the last fraction in the next term. So the first fraction cancels out with the last fraction in the next term. The first fraction cancels out with the last fraction in the next term. And so the first fraction cancels out with the last fraction in the next term. And if we continue, like I said, we're going backwards. So if we continue, technically it would be down here. Technically it would be down here because we just simplified. So if we continue, we have, let's take a look at the pattern that we have here. It's gonna be the last fraction crosses out with the first fraction in the previous term, and the last fraction crosses out with the first fraction in the previous term. For the last fraction crosses out with the previous fraction in the first term. Let's just pretend that there's another term there. So this is basically the same pattern that we had here, but it's just backwards, because again, here the first fraction crosses out with the last fraction in the next term, and here we have the last fraction crosses out with the first fraction in the previous term. And so this last fraction should cross out with the first fraction in the previous term, but there is no previous term, therefore we're going to maintain that. And this one, which is the first fraction, the same pattern that we had up here, the first fraction would cross out with the last fraction in the next term, but there is no next term. So therefore our sum is going to equal -1/3 plus 1 over 2n plus 3. And so now we want to find if this sum converges or diverges, and so we take the limit as n approaches infinity of -1/3 plus 1 over 2n plus 3. And so when we plug in infinity, well, this is basically very simple. This would just be the limit as n approaches infinity of -1/3 plus the limit as n approaches infinity of 1 over 2n plus 3. So provided that we can break up the limit by its property of addition, so the limit of a constant is just a constant, plus the limit as n approaches infinity of this would be 1 over 2 times infinity plus 3. So we have -1/3. It'd be anything multiplied by infinity is infinity. Anything added to infinity is still infinity. So we have -1/3 plus 1 over infinity. And anything divided by infinity goes to 0. And so we have -1/3 plus 0 equals -1/3. And so the series converges. And for your notes, this is what we call a telescoping series. Doodles.